Okay, we'll look at some of the homework problems in section 9.2, which deal with multi-stage experiments and also tree diagrams. Okay, a box contains 4 white balls and 3 black balls, and we want to complete parts A and B below. A ball is drawn at random from the box and not replaced. Then a second ball is drawn at random from the box. Draw a tree diagram for this experiment and find the probability of the event that the 2 balls are of the same color. Okay, in this case here, we're given 4 different tree diagrams. We want to figure out which one would fit this particular situation here. Okay, so here we got 4 white balls and 3 black balls. Okay, so here a ball is going to be drawn from the box and will not be replaced. So if I draw a tree diagram here, now say here this will be the first pull. It's either going to be a white ball or a black ball. And from this situation we have 4 white balls, so the probability there would be 4/7. And actually, there's a total of 7 balls in the box there, so that's where I got the 7 from. 4 white balls and 3 black balls will be 7. So the probability of pulling a white ball will be 4/7. The probability of pulling a black ball would be 3/7. Okay. Now, if you add 4/7 and 3/7, you're going to get 1 whole. So that means that some of these 2 branches here have to be equal to 1 whole. Okay. Now, on the second pull, in this case here, we're either going to pull a white ball or a black ball. And if the first ball was black, then we're either going to pull a white ball or a black ball. But this time, without replacement means that we're going to have 6 balls after the first pull. Okay, so if a white ball was pulled, then instead of it being 4/7, it's going to be 3/. Okay, now let's look at this one. Okay, it's not replaced. Okay, just want to make sure it's not replaced. Okay, so that means that there are going to be 3 balls in there out of a total of 6. So 3/6 will be 1/2. Okay, now I want to make sure that this is clear to you because there were 4 white balls. If a white ball is pulled on the first draw, then you're only going to have 3 white balls out of a total of 6 on the second pull. So it's 3/6. We reduce 3/6 to 1/2. But we're still going to have 3 black balls in the box. So it'll be 3/6, which is still going to be 1/2. Okay, because there's still 3 black balls in the box. Now, let's say the first pull was a black ball. So now, instead of there being 3 black balls, there are now 2 black balls out of 6. So the probability of pulling a black ball would be 2/6. But 2/6 is 1/3. Okay, and if the first pull was a black ball, that means that there's still going to be 4 white balls out of 6. So it'll be 4/6 reduced to 2/3. So this is what the tree diagram would look like. Okay, and in this case here, now it might be hard for you to see on here, it's going to be answer B. Okay, now to answer part B, the probability of the event that the 2 balls are of the same color. Okay, now let's go back to this. So here, all the outcomes are white, white, then white and a black and a white, black and black. Now what I'm going to do here is multiply each of the probabilities that are along each of the branches here. So if I multiply 4/7 times 1/2, that will give me 4/14, which will be 2/7. So the probability of pulling two white balls will be 2/7. And then the probability of pulling a white and a black would be 4/7 times 1/2, which would be 4/14. That's going to be reduced to 2/7. And then pulling a black and a white, that's 3/7 times 2/3, which would be 2/7. And then finally pulling two black balls, 3/7 times 1/3, that will be 1/7. Because it'll end up being 3/21, but we can reduce 3/21 to 1/7. Okay, so those fractions are in simplest form. Now we want the probability of pulling two balls of the same color. Okay, so here's an outcome where we have a white and a black and a black. So we're going to add 2/7 to 1/7, which is 3/7. So the probability of pulling two balls that are of the same color, which would be 3/7 as your answer. Okay. Now here's part B of the first problem here. Suppose that a ball is drawn at random from the box. Its color is recorded, and then the ball is put back in the box. So this represents a situation where we're dealing with replacement. The other one was without replacement. Then a second ball is drawn at random from the box. Draw a tree diagram for this experiment and find the probability of the event that the two balls are of the same color. Okay, so in this case here, I'll go ahead and draw the tree diagram. So as you can see on the first pull, you're either going to have a black, or it doesn't matter. Well, it does matter. Let's say white and then black. There were, of course, 4 white balls. So the probability of pulling a white ball will be 4/7. The probability of pulling a black ball will be 3/7. Okay. Now the balls are going to be replaced. They're going to be put back in the box. So that means you're still going to have 7 balls on the second pull. Okay. Let's make this white and then make this black. And then do the same thing here, white and a black. Okay. It really doesn't matter which one I put first. It's going to be the same. But in this case, on the second pull, the balls are, I still have 7 balls in there. So pulling a white ball in the second draw will still be 4/7 for that probability. And for the black ball, it's still 3/7. And the same holds true if the first pull was black, and then the second pull, the probability of pulling a white ball is going to be 4/7, and 3/7 for pulling a black ball. Okay, so that's what the tree diagram will look like. Okay, and in this case here, it's going to be this answer choice. Answer A. Now part B is the probability of the event that the two balls are the same color. Okay, in this case here, we list our outcomes here. A white and a white, a white and a black and a white, black and a black. And then again, we multiply each one of those out of those probabilities along the branch. So for a white and a white, that'll be 4/7 times 4/7, which will be 16/49, and that cannot be reduced. And then 4/7 times 3/7 will be 12/49. And then 3 sevens times 4 sevens, that again, 12 over 49. Then for the black and the black, 3 sevens times 3 sevens is 9 over 49. Okay, so we want the probability that the two balls are the same color. Here's one outcome, and here's the other outcome. So the probability of pulling two white balls is 16 over 49, and the probability of pulling two black balls is 9 over 49. So 16 49 plus 9 over 49 would be 25 over 49. Okay. So the probability of selecting two balls of the same color would be 25 over 49. Okay. So as you can see in that first problem, part A dealt with of drawing a ball at random without replacement, and the other one, this one, drawing a ball at random with replacement. All right, the next problem. A box containing 8 letters shown as charting, CHARTING. What is the probability of the outcome hang, HANG, in that order if the 4 letters are drawn one by one with replacement and B without replacement? Okay, so here we got two different scenarios here. One we're going to do with replacement. And with replacement, that means this, that the letter is going to be put back in the box on each subsequent draw. So in this case here, if we want to pull out the H, its probability of pulling out the H will be 1/8. And then the H will go back in the box. So the probability of drawing an A, again, that's going to be 1/8. And then the A will go back in the box. The probability of drawing an N, again, that's 1/8. And the G, with the N going back in the box, this probability will be 1/8. So here with replacement, the letter is going back in the box on each subsequent draw. So here you're going to have 1/8 times 1/8 times 1/8 times 1/8, which will be 1 over, and that's going to be 8 to the 4th in your denominator, which will be 4,096. So it'll be 1 over 4,096. Okay, so with replacement, the probability of the outcome, HANG, in that order, if the 4 letters are drawn with replacement, will be 1 over 4,096. Okay. The next one is the probability of the outcome, HANG, in that order, if 4 letters are drawn without replacement. So that means that the letters are not going to be going back in the box, which means the denominator is going to be reducing each time. So if we want to draw an H on the first draw, that probability will have to be 1 out of 8. Now that first letter will be out of the box, but it's going to be gone. That means you got 7 letters left. So the probability of drawing an A on the second draw will be, this time, 1/7. And then the H and the A are gone, so that means that you have 6 letters to choose from. So the probability of pulling an N, that's 1 out of 6. And the G, with the H, the A, and the N gone, there are 5 letters left. So the probability of pulling a G will be 1/5. Okay, so here we're going to multiply those probabilities together, multiply those fractions. Well, the numerator is going to be 1, so now the denominator is 8 times 7 times 6 times 5 will be 1680. So it's 1 over 1680. So the probability of the outcome, HANG, in that order, if the 4 letters are drawn without replacement, is 1 over 1680. Okay, so here you can see the difference between with replacement and without replacement. Okay, number 3. An executive committee consists of 15 members, 7 men and 8 women. 4 members are selected at random to attend a meeting in Hawaii. The numbers are drawn from a hat. What is the probability that all 4 selected are men? The probability that all 4 selected are men. Okay. Well, in the first selection, there's 7 men out of a total of 15. So the first selection is 7/15. Okay, now on the second selection, there's only going to be 6 men, but this time there are 14 left. So it's 6/14 for drawing a second male. And then for the third male, there are now 5 out of 13. And then the fourth male, this time they're going to be 4 left out of 12. So it's 4/12. Okay. So this represents the probability of picking the first male. This one, the probability for picking the second male. This one, the probability of selecting the third. And this one, the probability of selecting the fourth male. Okay. So as you can see, not only does these numerators decrease because we're picking all men, the denominators are decreasing because the number of members in that committee are being reduced. Because this is what an example of something that is without replacement. Okay, now if we simplify this, 7 times 6 times 5 times 4, the numerator is 840, because I'm sure they want us to simplify the answer. 840 over 15 times 14 times 13 times 12, that would give us 32,760. And if I reduce that in simplest form, it would be 1/39. Okay. And if you notice, I'm using a calculator, using my TI-83 calculator to simplify this in simplest form. So 1/39 would be the simplified fraction for the probability that all selected committee members are men. Okay. All right, number 4. Assume the probability is 1/2 that a child born at any time is a boy and births are independent, meaning the outcome of one does not affect the outcome of the other. What is the probability of the event if a family has 5 children, no twins, and they are all boys? Okay, so we know the probability of the first boy is the first one being a boy is 1/2, and the next is 1/2, the third is 1/2, the fourth is 1/2, and the fifth is 1/2. Okay, so in this case here, we multiply straight across. The numerator is going to be 1. The denominator is just 2 times 2 times 2 times 2 times 2, which is the same as 2 to the 5th. That's going to be 32. So the probability there that a family has 5 children and all of them are boys would be 1/32. Okay, so this should assist you with some of the homework problems in section 9.2.